In our last video, we already discussed how we define the matrix multiplication and addition, and how the concept of matrix multiplication is related with the transformation of a function, and ultimately learned that the matrix are same as a transformation. Matrix and transformation are actually same. So in today's video, we will discuss these things in detail, and we will discuss 3-4 methods of matrix multiplications. Okay, in our 12th standard we learned only one method of matrix multiplication, but in this video we will learn some 2 or 3 more methods of multiplying a matrix. First of all, we already introduced the concept of matrix, and we are little bit aware about the importance of matrix. So we know what is the importance of a matrix in solving a linear equation. Okay, so we will start our video taking an example. So let me write the example. This is an example, and according to the matrix algebra, we can write it as, I think you guys also know about this thing, this, where A is equal to 2, 3, 1, 1, 2, 4, 3, 1, 2. X is equal to X, Y, Z, and B is equal to 9, 13, and 11. I think you guys can see this. And how is this possible? This is possible because ax equal to b. If we multiply a and x, we will end up with this. Okay, we will end up with this thing, and this thing is ultimately equal to the b. Okay, so this is the thing we noticed. But what is the advantage of having this thing? Okay, is there any advantage? Yeah, if after writing this, writing the equation, system of equation in the matrix form, we have to notice one thing very clearly, is that we, in our last video, I told you that a matrix is nothing but a transformation. That's mean a trans A is a transformation, this matrix is a transformation, and this matrix, after the multiplication of this vector, this is returning this one. That's mean we have to find out the values of x, y, and z. Okay, so that after multiplying with it, we will end up with this form, this terms, these 3 values. Okay, this is the thing that I want to tell. So in transformation form, we can write this like this. This is a map T with R3 to R3. Okay, and what we have to do? We have to do that x, y, z are the variables. Ultimately, these variables, and this is these are the three components. This and this. Okay, this is the transformation, and this is ultimately ending up with 9, 13, 11. That's mean in a 3D, if I try to draw a 3D graph, okay, this is x, this is z, this is, let's say, y. Okay, that's mean here these are the 3 planes. Okay, we have to find out the value of the intersection point of these 3 planes. Okay, why intersection point? Because for which value of x, y, and z, okay, we are having this particular value. Okay, so one thing, in our last video we end up with a question that we are not writing the transformation with the form of the constant form. Okay, and that was a question. Not definitely you will able to understand all these things when we will study the transformation chapter properly. Okay, there will be no doubt about this thing, but for now just understand that this is the transformation and this is the matrix for it. Okay, the matrix is not for this one. This is a particular value which we are taking, and we want to find the value of x, y, and z for which this value is happening. Okay, so let us find out the value of x, y, and z. Okay, so we will try to find out the values of x, y, and z. So for this we will do a very interesting job. We will put the matrix method in our left hand side, and right hand side we will put the equation. Okay, and ultimately we will do both the things simultaneously. We will compare it. Actually, this is the same as I do in my last video, but that was the Chinese method. But it is our modern Gaussian approach to solving a linear equation. Okay, so let us do it. Okay, this is the thing. Okay, so first of all, what we do, we will just swap up these 2 equations. Okay, after swapping up these 2 equations, we will have Okay, this one, let me write. This swapping is allowed, so we will do the same thing. We will just swap up r1 and r2, and we will end up with 1 2 4. Okay, just like this we will swap this one and this one, and here we will also swapping up 1 and 2, this one. Now again, one thing we can do, we can multiply this equation with -2 and add with this one. Okay, so what we will do, we will multiply this equation with 2 -2 and add it in this equation. Okay, so ultimately we will have this. So we multiply this -2 and add it with this. So we multiply it with -2, that means -2x. Okay, so that means we will have 2x plus 3y plus z. Okay, and plus after multiplying it, -2x minus 4y minus 8z, and ultimately 9 minus 9 minus 26. So what we will have, this cancel out, 3y 3y minus 4y, 3y minus 4y, that's mean minus y. Okay, z minus 8z, that's mean 7z, and this is minus 17. So this is a valid operation. Okay, and again we will multiply it with -3. Okay, -3 and add with it. So what will we have, 2x plus 3y plus z plus with -3, that's mean minus 3x. Okay, minus 6y minus 12z equal to, what will be this, 11 minus 39. Okay, so we will end up with, this is y, this is 2z. Okay, so we will end up with minus 5y minus 10z equal to, this is 20 minus 28. Okay, so we will have these two equations, and these are all valid operations. So we will do the same thing here. Okay, we will multiply this first row, we will multiply first row with -2 and add it to second row. Again, what we will do, multiply first row with -3 and add it with third row. Okay, the same thing, 1 2 4, and this is going to be 0 0. Okay, -1 -7 -5 -10, and this is 13 -17 -28. Okay, and now again we can do one more thing here, is that we can multiply this second equation with -1 and this one with -1 to just cancel out the minus sign. We can do this also. So let me write this also here. 4z equal to 13. Okay, y plus 7z equal to 70. Okay, 5 plus 10z equal to 28. 5y. So now these two equation, number 2, this is number 1, this is number 2, we can multiply it with -5 and add it with it. So ax plus 2y plus 4z equal to 13. So these are all valid operations I am doing here. So this is y plus 7z equal to 17, and this is going to be minus 25, because after this will cancel out, and minus 35 plus 10 minus 25 z equal to minus 57. Okay, so I think for this case we already have the solution. From here we can find the value of z 75 by 27, and using putting this value of z in this equation, we can have the value of this also, 7 into 57 by 25, and using this value of y and z, we can put in the value, we can have the value of x. Okay, I think you guys are able to understand. So doing the same operation here, we will just multiply r2 with -1, r3 with -1. We will have 1 2 4 0 1 7 0 5 10 13 17 28. Okay, and now multiplying r2 with minus 5 and adding it with 3. We will have 1 2 4 0 1 7 0 0. This is minus 25. Okay, and 13 17 and minus 57. Okay, so just that. Now see, you did so many steps here, but for this one, for this case, you just need this much space and you solve all the equation. Now you can just put z here, x y and z here, and x y and z here, and you can solve the same thing here. Actually no, for matrix operations we are not doing the any other things. Okay, we are just doing the same thing. What we do, these are all legitimate operations. The swapping up of an equation, this is also legitimate. Multiplying it and then subtracting, this is also legitimate operation. Okay, then multiplying any number with any equation, this is also legitimate operation. Okay, so we are doing just same things. Okay, ultimately, so I just wanted to show you that we are not doing any other thing for matrix operations. We are just doing the same things what we did here. Okay, just repeating the things, but the process became very much easier. In this case the process was very much lengthy. We have to write the x y z terms, I mean all the times. We don't have to write the x y, the variables in that case. So lot of I mean we have lot of saving of space, saving of energy, lot of other advantages also we will see in our later videos. Okay, so this is the advantage I wanted to show you. So so we can find the values of x y and z from here. Okay, so just put these values here. Okay, put these values here. So ultimately we end up with the thing is that ax, that's mean ax equal to b, that's mean we will multiply the ax, the values of x y and z in a, and we will end up with this. The transformation is also like this. Okay, the transformation, if we put these values in the transformation, we will end up there. Okay, so that's mean transformation and the matrix multiplication is the same. They are giving the same result. Okay, we are just, I mean these are how much they are correlated. Actually they are the same thing. Okay, this is a transformation, and actually this is ultimately ending up with this. So one question that definitely comes to our mind, that is all transformation are a matrix? So the answer is no. Okay, all transformation are not a matrix. This transformation is actually obeying a rule, and we will ultimately know what the rule this is obeying. For this is a matrix, and each, if you saw any matrix, then this is definitely a transformation. Okay, but any function is not a transformation. A transformation is a matrix, and is a matrix is a transformation, but all the functions are not transformation. Remember it. If a function obeys some rules, then that function will be a transformation, linear transformation. Okay, so we will learn these things in our further videos, in the chapter linear transformation. Okay, now we will go through that the multiplication process. Okay, let me take two matrices and we will multiply the two matrices in 4 ways. Okay, actually first of all we discover the Cauchy, Arthur Cayley actually defined the matrix multiplication like the composition of the function. Okay, how we compose the result, and laterly the mathematicians just tried to find a rhythm. How can they match the result easily, just by seeing, but just by having to, because if you have a matrix for all the, if you have two matrices, okay, so it is quite a difficult work to make the transformation, and then composing them, and ultimately having the ultimate composition matrix, and then writing this matrix form. This is a very lengthy process. So just mathematicians so discovered a method so that we can find the result, the composition of the two functions very easily. So the matrix matrix multiplication did do this kind of things. Okay, so let me take two examples and I will discuss the 4 way of multiplication. Okay, these are two matrices A and B. So we will multiply our, what we naturally know, the row column multiplication. Okay, because we row and then column, so this is called the row column multiplication. Okay, so this is the natural process what we learned in our 12th higher secondary. So 1 into 1 plus 0 plus 4, that's mean 5. Okay, that's then again this one 2 0 and again 0, that's mean 2, and now this one 0 0 and this is 2. Okay, the simple multiplication what we learned in our higher secondary. So this is going to be this, and 5 6 1. So I think we no need to I show the multiplication used, or I think everybody know this. multiplication. Okay, so I am not telling all the thing in detail, just this row and multiply the column. Okay, the component wise, 1 into 1, 0 into 0, 2 into 2, multiply it, then plus it. That's mean like the dot product. This is a vector, let's say consider it as a vector 0 1 0 2, and the last product dot product with 2, and the answer will be this first term. Okay, the first term. Now again this vector and then dot product with this vector, we will have this component, and again this one with this one, so all the terms are coming. Okay, for row column multiplication. Okay, and second is column multiplication. Okay, column. In column multiplication, what we do, the column of A multiplied with column of B. Okay, that's mean like this, we multiply this term with this column. Okay, that's mean like this. Okay, 1 0 3 0 1 0 2 0 1. Okay, and we will multiply this one with 1 0 2. Okay, this is actually A matrix. So again with A matrix we will multiply this to second column 2 1 0. With A matrix again we multiply this third column 0 0 1. Okay, and what the result will be, and column, this one is the column of B, first column of B. So multiply 1 with this, multiply this with this, and multiply 2 with this column. That's mean multiply, if we multiply 1 with this column, we will have 1 0 3. Now add 0 with this column. Okay, 0 0 0, again plus 2 with this column, 4 0 2. Okay, now again similar way we can find this thing also. Okay, what will be this one, and ultimately we will end up with this is this. So this one is the first column, this one is the second column, this one is the third column. So first column is 5 0 and this is 5. Okay, and this one is 2 1 6, this one is 2 0 1, just same as this one. Okay, see, these two results are same, 5 2 2 5 2 2 0 1 0 0 1 0 5 6 1 5 6 1. Okay, now third process is row multiplication, column multiplication, then row multiplication. Okay, row multiplication A B. So just the row of this column and row of this B. Row multiplication is just like the column multiplication. Here we start with this one, here we start with this one, multiply this one with this, then this one with this one with this, and ultimately add up, and we have the first column. Okay, similarly here we will start with left. Okay, we will multiply 1 with this row multiplication, this is row, 0 with this row, 2 with this row. Okay, then we will end up with the first row. Okay, 1 with this row, if we multiply this one, 0 with this row, that means 0 1 0, and 2 with this row, that means 4 0 2. Okay, that means we have the first row. Now again this 0 with this row, that means 0 0 0. Okay, 1 with this row, that means 0 1 0. Okay, 0 with this row, 2 0 1. Okay, and 3 with this row, 3. Okay, 6 0, and 0 0 0 plus 2 0 1. Then ultimately we will end up, just add them, 1 0 4, that means 5, 2 1 0, that means 3, sorry 2, sorry, I made a mistake, this is going to be 0. Okay, 2, because 0, so 0 0 0. Okay, and this is again 0 0 2. Okay, this is 0 0 2, 0 plus 1 plus 0 equal to 1, 0 plus 0 plus 1 equal to 1. So 2 1 1. Okay, I think I made a mistake here, 0 0 2 2 0. Okay, this is going to be 0 0 0, you know, because I made a mistake, 0 0 0, multiplying 0 with this column, 1 with this column, this row, 0 with this row, that means this is 0 0 0, that means this is 0 1 0. Okay, and this one 3 0 2, that means 5, 6 0 0, that means 6, and 0 0 plus 0 plus 0 plus 1 equal to 1, and you will end up with the same result as of the before. 522 522 010, that means 010 565 561 561. Okay, now one last, and this is obvious, row column 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 row row, that's mean column row operation, column row multiplication. So this is just like the row column multiplication. Okay, what we will do is column row multiplication, that's mean column of this matrix, row of this matrix. Okay, that's mean column of this, that's mean 1 0 3 multiplied by row of this, that's mean 1 2 0. Add, then column of this 0 1 0 0 1 0, row of this, that's mean 0 1 0 0 1 0, column of this 2 0 1, and row of this 2 0 1. Okay, now just multiply them, okay, 1, okay, 2, multiply 1 with this 0 0 with this, and 3 6 0. Okay, now again 0 with this 0 0 0, 1 with this 0 1 0 0 0 0, and ultimately this is 4 0 2, okay, and 0 0 0 2 0 1. And now just add them, 1 0 4, that's mean 5, okay, 2 0 0, that's mean 2 0 0 2, or 0 1 0, and ultimately 5 and 6 plus 0 plus 0 6, 0 plus 0 plus 1 1, again the same result as before, you can see it. So these are the 4 multiplication process that we need to understand. So in today's video we just saw some computational things mainly, and some other sum and bit concept. Okay, one thing notable is that that's mean the ultimate answer is the same, but the process of multiplication is different. What I already told you in the first half of this video, that Arthur Cayley actually defined the thing that the multiplication, we have lot of matrices. Okay, so we need to find an operation relation. So for this he defined the addition and the multiplication. So he defined the addition just like coefficients adding, and this also has significance, this is also not random, I already told you. And the multiplication actually the composition of two functions, how two functions are composite, if composing, and ultimately the coefficients are the multiplied matrix. Okay, this is the thing. And the actually, but after mathematicians just try to find the methods, so that we can just looking at the matrices and we can just do the step, and we can ultimately because in matrix you see you don't have any transformations here. Okay, we don't know what is actually the transformation here, but inside it there are actually working a lot of transformations, but we are not working with the transformation. If we don't have the methods of multiplications, then it is very much difficult for us to compute that if we have two matrices like this, and you let's say you don't know any of the multiplications, then what we have to do, you have to make the transformations first. Okay, t1 t2, then you have to compose them, and after composing them you will have the coefficients and you have to write them like this. So this is a very much lengthy process, so better you just do this, follow, I mean remember one of the process and just multiply. But I will suggest you to remember this process, because this process will help you to solve a lot of questions in future. Okay, so this is all about today's video. Thank you.